All right.
Yeah, that's why you have to address us for no one.
So it's legit. Okay. So, right. We've been factoring polynomials, right? Trying to find the zeros and things like that. And we realize, though, that there's only, a limited number of polynomials that we can work with and factor using the strategies that we know. Okay. We are able to sometimes get around, our inability by, like when we did number 3 for the warm-up, right, where I gave you a factor, and then you were able to use that factor using long division or synthetic division, and the result, we were then able to use our strategies, okay? But the problem is, right, how do you come up with a zero that, and when it's not given to you, right? How do you come up with something that we're not given in the first place? And so there's a lot of possible ways you could guess and check, right? There's an infinite number of numbers you could potentially guess these zeros of a polynomial, and you don't want to have to do an infinite number of guesses, right? Because what if you're a bad guesser? Okay, so we're going to use something to help us narrow down the kinds of guesses that we make, and that is going to be using the rational zero theorem. Okay. The rational zero theorem is going to help us narrow down the number of guesses that we need to take, or the kinds of guesses, or what our bank of numbers we're going to guess from. Okay, so here it is. Okay, so if p of x is a polynomial, so again we're dealing with polynomials. Okay, polynomial function with integer coefficients. And if m over n is a zero of p of x, okay, right? Because our zeros, they're sometimes just integers, right? So like 3 or 4, but we could have zeros that are 1/2 or negative 2/3, whatever kind of thing. All right. If m over n is a zero of p of x, so again, i.e. p of m over n equals 0. Right? So if you plug m over n into your polynomial, it gives you 0, right? That would indicate that's a 0. Then m is a factor of the constant term of p of x and n is a factor of the lead coefficient of p of x. I know, this is like the most writing ever. Right? We're not done yet, but that's where we're going to start right now. Let's stop and talk about this. Okay? So we have a polynomial, okay, and we have this like 0, okay, that exists for it, okay, a rational 0, right? It's rational because m over n, that's a fraction, right? M is an integer, n is an integer, okay? So if m over n is a 0, then we know that m has to be a factor of the constant term. N would have to be a factor of the lead coefficient. And we're going to use this fact to then allow us to limit the number of numbers that we pull from when we make our guesses. Okay, so let me just put this in other words. Okay, any rational 0 of p of x will be in the form m over n, where m is a factor of the constant, n is a factor of the lead coefficient. Okay. That's how we're going to be using this. Okay, so I'll show you an example here too, of course. show an example here too. Okay. So we're going to create a list of possible rational zeros by finding the factors of our constant term, finding the factors of our lead coefficient, and then creating all this list of possible zeros, rational zeros. Okay? Of course, do the zeros for a polynomial have to be rational? No. They could be irrational, right? Stuff that involves square roots. Or they could be imaginary. Okay? So, again, even with this, we're not going to have a way to solve every single polynomial that we come across. Or to factor every single polynomial. Okay, bless you. All right, so here we go. Example. Let's see it in action, right? So we'll first list all the possible rational zeros of this polynomial. Then we're also going to factor completely, because that's really the point of this thing, right? Oops, off the screen. There we go. Okay, here's our polynomial. P of x is x to the third plus 2x squared minus 19x minus 20. So again, we're going to need to identify the constant, okay, because our numerator of our zeros will be factors of that constant. And we also need to identify our lead coefficient because the denominator of our zeros will be factors of that. So what is our constant term here in this polynomial? Carol?
-20.
Yeah, the negative 20. So there's our constant. Right? It doesn't have a variable attached to it, so it is unchanging. And minus 20 will always be minus 20. All the other terms have a variable with it, so they are not constant. They are variable, able to be changed, right? All right. And then how about the lead coefficient? What's that in here? 1, right? It's just the number in front of the x cubed, so that's the lead coefficient. Okay, is 1. All right, so our possible rational zeros, we're going to have factors of that 20. And you can say negative 20 or 20 there. It doesn't kind of matter because all the factors of 20 will be the same as the factors of negative 22. So I'm just going to put 20. But if you want to put a negative 20, that's fine. And then we'll over the factors of 1. Okay, so this is the format of all of our rational zeros, right? M over n. M is a factor of the constant, n is a factor of the lead coefficient. So we're going to do factors of 20 over factors of 1. Be careful. It's a little weird, okay? We're putting the number at the end on top. We're putting the number at the front on the bottom. Okay, so be careful. That might be a little counterintuitive, right? For whatever reason, intuition in my mind, it makes sense to put the 1 on top, the 20 on the bottom. It's the constants on top, the lead coefficients on the bottom. Okay. And there's a reason for that, and we can discuss that, or I can kind of try and convince you that why that has to be so if you need to see it. But if you're okay with just accepting it, that's okay too. Okay, so what are the factors of 20? 1, 2, 4, 5, 10, 20. Anything else? Yeah, so then that's all the positive numbers. But what about negative 1 or negative 2 or negative 4 or negative 5 or negative 10 or negative 20? Yeah, we have to do plus or minus here.
Oh, we can remove each one.
Yes, sir. And that's why I left some space. Sorry I didn't warn you guys. There you go. Okay? All right, but the nice thing is, for the bottom, the denominator, what are the factors of 1? 1. So plus or minus 1. Okay? So let's list the list of the possible rational zeros. Okay, so here's our list. I'll make a little colon there. Okay? So our zeros are going to be these fractions. So 1 over 1, or just 1. 2 over 1, or just 2. 4 over 1, so 4. 5 over 1, so 5. 10 over 1, so 10. And 20 over 1, so 20. Okay? And it's again plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. This is our guess and check bank. 2, 4, 6, 8, 10. You only have 12 guesses that you have to make. Wow. Yeah. Okay, so let's make a guess. Someone make a guess here. Pick one. Christian. 5. Christian chooses 5. Okay. Let's see if he chose wisely or poorly. So we're going to do synthetic division here. If you really want to use long division, you can, but I would encourage you to, use synthetic. It's faster.
Wait, so we take a number and go through.
I agree. Yet here we are. Okay? So, let's go, right? So the 1, and then the 5, and then the 7, and then the 35, and then 16, and then 80, and then 60.
No.
Did Christian choose wisely?
No.
He chose
Ethan,
poorly.
Alright, I'll pick one. Sorry.
Okay? All right.
I want to pick one.
Ethan wants to pick one now.
I want to pick. I'm picking 2.
You're picking 2.
Oh, dude.
All right, we'll try 2. 1, 2, negative 19, negative 20. All right. Drop the 1. So we get 2, 4, 8, negative 11, negative 22.
Whoa, this is so close.
He chose
Yeah, I was
poorly.
closer than you, Chris.
Aubrey chooses 1. Just positive 1? All right, positive 1. Here we go. 1.
She's definitely right.
19, 20. Okay, so 1, 3, 3, negative 16, negative 6, negative 36. She chose poorly.
Yo, can we choose one of the negatives?
So,
Wait.
I really feel like it's negative 2. Wait, can you what's the answer?
You think it's negative?
You know what I mean?
so we pick something between 5 and 2? Okay.
Because 5 is too high and
Because you're seeing the remainders kind of
Yeah,
I
so
don't
like
know that
zeros between those two?
Got 4.
That might be a strategy. I don't know. That's a good question.
I don't know.
That is interesting that you picked it because there is a 0 that is between 5
Yeah,
and
it's
2.
negative 2.
Yeah.
One of the zeros is between 5 and 2. Jen!
I
I
just
mean,
got
you can cross up all the numbers above 5 because all the numbers of the bottom are positive.
Okay.
It's gonna be an up and down.
So I see what you're saying. Okay, so yeah, this is the strategy Mr. Thompson teaches, right? Yeah, so that's good because I don't know some of these other strategies and stuff like that. I literally just like guess and check the thing until I find something that works. But so did you hear what Jandra said? So 5, okay, a positive 5, right? We get all positive numbers here, and then the remainder is 60. So anything above positive 5, okay, so positive 10, positive 20, is going to get even bigger and bigger out of control. So no
If
good.
it's negative, wouldn't
Okay.
it just be the opposite?
So I don't know if I can say that.
That's not how it works.
Okay, but let me make a guess here. We'll guess negative 1.
Are you guessing or do you know the answer?
I am guessing.
Yeah.
He just happens to guess correctly.
Of course he's not.
He's the
He's got the script. He's got a whole
I have my script right here. I have all
class
the
plan.
answers.
Did you see what it
You have to
was?
edit that part out.
What's all right?
The fans.
It is. But I wanted you guys to get a taste because this is what you are going to experience when you do these.
Only a taste.
This is taste.
Oh, they Reagan's wrong.
Okay. Guess right. No, Ray's not wrong. You'll see her thing that she theorized there. But I'll show you. Okay. So, what's our result here?
0.
Well, okay, so that means negative 1 is a 0, right? Negative 1 is a 0. But my point is, what also is this right here? It's a new polynomial, okay? It's 1x squared plus 1x minus 20. Do I need to keep guessing here?
No.
we know how to factor quadratics, don't we? If they factor, right? You can use the AC method or just guess and check. My point is that once you get down to a quadratic, you no longer need to guess and check anymore, right? You can just factor it, right? Does x squared plus 1x minus 1 factor? Yes. What does it factor to be?
X plus 5 times x minus
Yeah, minus 4 plus 5 or plus 5 minus 4, yeah, whatever order you want to get there, that's fine. And so, yeah, there's there's your 0, Reagan, you were predicting. 4 is between those two. That's an interesting idea. I'm curious. If there is something to that there. Okay. No, but she would have if she had just looked. Between positive 2 and positive 5 is only positive 4, so that would have given her one of the zeros. If, again, if that is true.
I think
there's
a number in between 2 and 5.
Well, it's because you're looking at the remainder, right? Reagan, you look at the remainder?
Yeah.
Yeah, because between negative 42 and 60 is 0, and you're looking for a 0 to be the remainder.
I'm just saying you could have just said
I
plus
don't know.
4 minus
Anyway,
4.
I'll have to take a look at that. We'll see.
Just suck it up.
No, I didn't say you're wrong. I just said you could have just said either.
All right, well, let's get back on track, though, because, again, I don't know right now, but that is interesting for sure, but we're going to continue on with what we've got right here.
Who are you arguing with? I said you. I didn't say you were wrong.
Okay, so that negative 1, remember, by the way, that means our factor is x plus 1. So the fully factored polynomial would be that right there, like the x plus 5, the x minus 4, the x plus 1. Okay, and that's our final answer.
All the coefficients have to be.
The x plus 1, because negative 1 works, the factor then that would yield a negative 1 would be x plus 1. Right? X plus 1 is the factor that yields that negative 1. Okay? Negative 1 is the 0. The factor then would be x plus 1. Because the 0 of x plus 1 is negative 1. That's the idea. Okay? So that's what we're going to be doing with this rational roots. That's what we're doing with rational roots. Or rational zeros.
Not so much for the day.
No, we got one more word to do.
Plus guy from.
Uno más. What's that? This one?
Yeah.
Because negative 1 worked. That's our 0. So then the factor that would give us that would be an x plus 1. Right? The 0 of this is negative 1, which is where that came from in the first place. So that gives us the factor of this. And then, of course, we then took our answer and factored it, so all three of them together make the full polynomial. Right? Make sense? All right. One more here. I'll get you guys started, and then we'll I'll let you guys kind of finish it off there maybe or something. Well, we'll see. Anyway, no, never mind. I'm not going to do that to you. Already gave you the answers. Well, hopefully no one remembers what I just wrote. Okay.
Dude, I got lost during
All right. Let's try this. P of x equals 6x to the third plus 7x squared minus 1. Same idea. We're going to find the zeros. We're going to list all the possible zeros, and then we're going to find them in factor completely. Okay. So again, you can see the situation we're in here, right? We cannot factor by grouping. We cannot find a GCF. It's not in a quadratic form. There's no difference of cubes here, okay, or sum of cubes, right? Difference of squares, anything like that. We're stuck, okay. But we can use our rational roots here. So, what's our lead coefficient? Or sorry, what's our constant term here? -1. Okay. What's our lead coefficient? 6. Okay, so constant. And then lead coefficient. Okay. So then, in the numerator are the factors of that constant. So the factors of 1. Right. And then we'll do the factors of 6 in the denominator. Okay, so right, in the numerator, just plus or minus 1. In the denominator, plus minus 1, 2, 3, and 6. Okay, so in other words, what's our list? So the list of possible rational zeros? Okay. So it would be, so it would be 1 over 1, so plus or minus 1. 1 over 2, plus or minus 1/2. 1 over 3, so plus or minus 1/3. third, and then 1 over 6 plus or minus 1/6.
Do we have to write factors of 1 and factors of 6, or can we just write 1 over 6?
It's your choice, whatever you want. As long as you can give me this, as long as you can produce a list like this, however you want to organize your writing, your work is fine. As long as you can produce this list right here for me, then I'm okay. Okay. So yeah, if you want to cut stuff out or whatever, that's your choice. All right. Well, let's try it again here, right? So I'm not sure if I used a different second example in my second block class. I'm not sure if I would prefer to use that or not here. Anyway, we'll go with this because we're already here, right? So, okay, let's guess.
-1.
-1? -1.
Why in God's name is it?
All right, so what are our coefficients going to be across the top here? It'll be 6, right? And then 7, and then 0, and then -1, right? Okay, because we don't have an x term. Okay. Very good. And -1 works.
Is that common?
No, it's just that I'll say, I could write these problems to be like awful and like torturous for you if I wanted to. I could make them be like the gigantic numbers maybe, or the fractions and stuff like that. And it's just,
No, he gives us
I will try to make it easy on you. Okay.
Yeah, on the notes, easy. And then I get brain tumors.
There you go. Right, exactly.
Great. You go home.
Okay, so we're not done yet though, right? We got now a quadratic.
And then I just like pass out.
Okay, so 6x squared plus 1x minus 1. Do not continue trying to guess and check answers once you do a quadratic. See if you can, you should factor it using your normal quadratic strategies, AC or a guess or check. Right? So yeah, we're going to use AC method here maybe. Okay, so 6 times -1 will give us -6. We need two numbers that multiply -6 but add to make 1. 3 and -2. So we'll break up that middle term there. Okay, like that. Group the first two, group the second two. From the first group we can take out a 3x, and we're left with an x plus 1. From the second group we can take out 2x plus 1. From the second group we can take out a -1, and we're left with 2x plus 1. And so we have 2x plus 1 times 3x minus 1. And then our old factor, I'm sorry, off the screen. Yeah, and so then we're going to have p of x as our final answer. P of x is x plus 1 from that original 0 that we had right there, and then 2x plus 1, and then 3x minus 1. And voila. Yeah, that's okay.
Huh?
So, questions on any of that?
Well, I will later.
I'm going to, question it. No?
Oh, never mind.
You okay? Okay. So real quick, before I show you guys, before I get started on the homework, because I'm only going to show you 2 examples, I want you guys to practice this on your own. I do want to show you the example that I gave to my second block class, just to kind of give you a hint here at something a little bit, another like kind of twist on it, right? So let me zoom this out here a little bit. Okay. So in my second block class for our second example, we did an x to the 4th. Okay. And the 24.
So you went off the script.
So I changed it up because I wanted to try something different. Okay.
That's really.
So just real quick, so you can see. Okay. Same kind of setup. Your factors of 24 in the numerator, factors of your lead coefficient in the denominator. All the possible zeros listed out. No big surprises there, right? But the issue then, right, is once you find one zero that works, you are not done. Because after you find one zero that works, you're now down to a cubic, right? If you start with something to the 4th, finding 1 0 means that you are now back to a cubic. So you have to continue, and you can just, the nice thing about synthetic division is once you get one of your answers, you can then just add a new box in, okay, right next to it, and then continue on. You don't have to write a whole new problem. You can just continue from your results, okay? Another thing you want to keep in mind too, is if you have to do more than one, again, if we're starting with to the 4th power, and you need to find 2 zeros before you get to the quadratic, you might have to re-guess the same zero, right? There are such things as double zeros that occur twice. So just because you use -1 and it worked once, it might work again. So you might have to check that too. If you find that it doesn't work in the original, it will certainly not work in the second one there too. So keep that in mind as well. Just for some strategy.
Another one.
Because this would be a cubic. If we started with something to the 4th power, right, the answer here, this result would only be a cubic. You can't factor cubic just yet. I mean, you can try and see if you can factor by grouping or something, but it's
She wants
not
to
gonna
go
work.
all the way down to the x squared.
You need to get down to a quadratic before you can then factor using your other methods. Unless you see in the results that it's like a grouping problem or, difference of cubes, some cubes, that kind of thing.
So when you get it to cubic, you still have to use one of the numbers.
You got to find, yeah. Now, you can, once you get to this step, you can recheck your constant and your lead coefficient, see if you have a smaller list. But I still had my constant was 24, my lead coefficient was 1, so I couldn't change my list. It was the same list still. Okay. But like I was trying to say there, Nathan, that if you, in your earlier work, if you had guessed stuff and found that the earlier work, something didn't work, you don't have to re-guess those numbers. If it didn't work with the original, it's not going to work for, the factoring thing again. So you can kind of
So you're telling me it could have taken me 16 tries to figure out the first part of it?
potentially, if you're a very bad guesser. Well, no, not 16 because there's 4 zeros. So it would, 1 out of 12, I guess, or 12 tries from 30 pounds.
I'm gonna go vote for 12.
Okay, but you'd have to be a very bad guesser. Okay, so understood. All right, so let's get you guys started on the assignment then. Okay, it's 3 problems, but that's because these can take some time, especially if you're bad guessers.
Oh yeah, that's right. I saw that one.
Okay. There's also a place for you to post the Schoology should you finish early, and really with 20 minutes left in class, you might be able to get it all done. If you want to spend the time instead kind of preparing for tomorrow's quiz, I'll understand that too, that's fine. Okay. That's cool.
Oh, so this going to be on the quiz?
This is not on the quiz.
No, it's homework. It's just it's on the thing.
So that about the number.
Okay. 1, 3, 9. Question. Okay, let me stop the video here real quick and then I can. Yeah. Oh yeah, go.